the object that crossed our solar system uninvited. It did not announce itself with fire or impact, and it did not slow down as it passed, moving instead with a confidence that suggested it did not belong to the sun at all. For a brief window of time, an object entered our solar system, ignored its rules, and then continued on its way, leaving behind questions that still have no comfortable answers. To understand why this moment matters today, we need to revisit how astronomers think about boundaries. For centuries, the solar system was treated as a closed neighborhood, shaped by the sun's gravity and populated by familiar residents whose paths could be predicted. Modern science refined that picture, but the assumption remained the same, that objects within our system originated here and followed patterns shaped over billions of years. That assumption quietly collapsed when this visitor was detected. Its trajectory was unlike anything previously recorded, moving too fast and at an angle that ruled out a solar orbit. Calculations confirmed what seemed impossible at first glance, that this object was not bound to the sun and had come from interstellar space, passing through our system as a temporary guest rather than a permanent resident. As telescopes raced to track it, every observation raised new uncertainties. Its shape defied easy classification, its brightness fluctuated unpredictably, and its behavior did not align cleanly with comets or asteroids. The object offered no clear signature of origin, only evidence that it had traveled immense distances before briefly intersecting with humanity's line of sight. What made the encounter unsettling was not the object's presence, but its indifference. It was not captured, altered, or influenced in any meaningful way. It simply passed through, unaffected by curiosity or scrutiny, reminding humanity that the solar system is not isolated, but exposed to a much larger, more dynamic cosmic environment than previously imagined. As scientists gathered more data, the visitor began to challenge every familiar category, because each new measurement seemed to contradict the last. Its acceleration could not be fully explained by gravity alone, yet it displayed none of the typical features associated with outgassing comets. There was no visible tail, no cloud of debris, and no obvious signs of material shedding that might account for its changing speed. The lack of clarity forced researchers to confront the limits of their observational tools. The object was already leaving the solar system by the time its significance was understood, shrinking rapidly against the background of stars and denying extended study. Every calculation had to be made with incomplete information, transforming analysis into a race against time rather than a methodical investigation. Debate intensified as hypotheses multiplied. Some proposed exotic forms of natural matter shaped by extreme conditions in distant star systems. Others suggested the object's behavior could be explained by unfamiliar physical processes acting on a scale rarely observed. Each theory fit fragments of the data, but none offered a complete explanation, leaving the object suspended between categories. What unsettled the scientific community most was how easily the visitor had slipped through unnoticed until it was already on its way out. Detection systems were designed to monitor threats from within the solar system, not objects arriving from beyond it. The realization that something could enter, pass through, and leave with little warning exposed a blind spot in humanity's cosmic awareness. As attention focused on the object's origin, a broader implication emerged. If one interstellar visitor had crossed our path, others likely had as well, arriving and departing long before humanity developed the tools to notice. The solar system, once imagined as a stable and isolated domain, began to feel more like a crossroads, quietly intersected by travelers from distant stars. The conflict sharpened as interpretations of the object's behavior began to diverge sharply, because the data supported multiple explanations that led to radically different conclusions about the nature of the universe. Some researchers argued that the visitor represented a new class of interstellar debris, fragments ejected during planetary formation in other star systems, carrying unfamiliar properties shaped by environments far more extreme than our own. Others were less comfortable with that explanation, pointing out that several observed characteristics resisted even the most flexible natural models. The object's shape appeared unusually elongated or flattened. Its reflectivity changed in ways that defied expectation, and its motion suggested forces acting upon it that were not fully understood. These inconsistencies fueled speculation, blurring the line between cautious hypothesis and controversial interpretation. What made the debate intense was not sensationalism, but uncertainty. No additional data could be collected. The object was gone, moving too fast and too far to be recalled by any telescope. Without the possibility of verification, arguments relied on probability rather than proof, forcing scientists to weigh which unknowns they were willing to accept. The deeper conflict lay in how science responds to singular events. Reproducibility is the cornerstone of confidence, yet rare phenomena do not offer second chances. The visitor's uniqueness placed it in an uncomfortable category, important enough to demand explanation, but insufficiently observed to settle the matter conclusively. As discussions continued, the object became a symbol of something larger than itself. It represented the idea that the universe is not obligated to provide neatly packaged evidence, and that humanity's models are provisional maps rather than complete descriptions. When something falls outside those maps, the challenge is not to force it to fit, but to decide whether the map itself needs to change. The climax of the story was not a conclusion, but a shift in perspective, as the scientific community accepted that some encounters are defined by their ambiguity rather than their resolution. The interstellar visitor did not leave behind certainty, but it permanently altered how humanity thinks about what can cross the boundaries of the solar system without warning. In response, detection strategies began to change. New surveys were designed to scan the sky more frequently and more deeply, not just for objects bound to the sun, but for fast-moving visitors arriving from beyond it. The goal was no longer only to catalog familiar threats, but to recognize the unexpected before it slipped away. The encounter also carried a quieter lesson. Humanity often imagines space as something distant and detached, yet this object demonstrated how connected star systems truly are. Material shaped in one corner of the galaxy can wander for millions of years and briefly intersect with another, carrying with it a silent record of environments we have never seen. Today, the object exists mostly as a memory in a dataset, debated and reanalyzed as new ideas emerge. It did not bring danger or discovery in the traditional sense, but it challenged a deeply held assumption that our cosmic neighborhood is closed and predictable. Sometimes the universe reveals itself not through answers, but through fleeting visitors that refuse to explain themselves. And when that happens, the most honest response is not certainty, but curiosity. Subscribe to join the journey. The